this whole recording thing, now that you're actually recording,
Yeah.
Should
What I'm supposed to be doing in the past 30 minutes? Yeah.
Yeah. So, I'm actually scared to tell my parents that you do this.
Okay.
Because they're going to use it as getting mad at me for being disruptive during class. So.
You think they're going to listen through and pinpoint your voice?
No, but I said that insane. And it's for comments like that get me in trouble.
I'll start the recording over.
Filters, everyone. Time to go.
Okay, but you don't understand. My phone is like. I'm not gonna tell them.
Okay, there we go.
I'm saying you.
There we go.
If you ask me, hey, is there something? If we have to cross that bridge when we get there, we will. Yeah.
Hey, do you
Yes.
want to just film your class?
Yeah. If we cross that bridge, I'll let you know. How's that? Surely to goodness, there are only 14 of you. I'll know when it's your people, so I'll be like, hey, by the way.
Well, their last name's not Gordon, so good luck.
They'll reference you in some way, I pray.
Hey, Jackson Gordon.
Exactly. Just call them out full name on my YouTube channel, let me tell you. Okay, so talking about how to analyze. So this is why the ADHD kicks in, I'm telling you. So basically, different kinds of variables, if it's categorical or quantitative, require different kinds of displays. And that's how they're going to know if you know what you're doing or not, if you knew it was categorical or quantitative, because you're going to pick the wrong kind of display. So you're like, display? Your typical thing you already know how to do. You've made a pie chart before. Bless you.
I didn't hear a sneeze.
You've made a pie chart before, and you use this type of graph when you want to emphasize each category's relation to the whole. So why would you, a lot of times what's cool about statistics is, especially in the free response questions and questions where they want you to do your own thing, you get to pick how we display it. So here's the arguments for each of them. The cool thing about a pie chart is, since the pie is supposed to be 100%, and you show, wasn't it 21.7? So if you saw that business was taking up 21.7% of the pie, that might help something or other. So I like pie charts. Bar graphs are also useful. These graphs display the distribution of a categorical variable. And we use this kind when we still want to compare parts of the whole. And then there's also the option of a two-way table. And it's a table that describes two variables and counts or percents. Now, we're going to use all three of these. I'm not going to say we're not, because we are. But if my go-to of what I'm going to use is probably a bar graph. If I'm picking, I'm probably going to go with a bar graph, because like a pie chart, it still reflects the whole. And what's especially important in it is that keyword I'm telling you we're going to always be looking for of distribution. It does a better job of displaying the distribution or the spread of the data. Oh, Lord. You're like, Miss Compton. It's Friday. Jeez Louise. Exactly. Exactly. Okay, so you're like, okay, we're going to make these different kinds of displays. I know what a bar chart looks like, bar graph. I know what a pie chart looks like. I got this. So then we get to words you don't know, and eventually I swear I'm going to say them enough, or you'll use them enough, you will. If we want to analyze it, so we displayed it, and now we want to figure some junk out. The marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values, that variable among all individuals described by the table. And then a conditional distribution of a variable, it says marginal the distribution of values, whereas conditional has a specific value of another variable. Okay, do I honestly expect you to know the word marginal distribution or conditional distribution yet? No. I swear to God, when we use it, I will reference it and be like, here it is. Here you go. But at least it's listed in your notes and we can reference back to it. Okay, we say there's an association between two variables if one variable tends to occur in common with specific values of the other. You've heard association before. I mean, you know of associations now. You have good grades, you probably scored well on the ACT. There's probably an association between your grades and your ACT score. There's probably some sort of association. You can think of lots of other associations. Well, and there are lots of arguments against those and for those. You can think of other associations. You know, you're like, oh, doesn't drive well, and then you automatically assume it's a certain gender.
Whoa.
There are a lot of associations we tend to make. I'm just saying, there are a lot of associations we automatically make in our head. Okay, and so finally an example.
AP Stats is just racism.
I know, straight up. It's preach. So here's an example about cell phones.
I don't have that.
I know, right? And we're going to reference the Pew Research Center, and they asked a random sample of keywords we should notice in life. Random sample. What does that mean now that Pew's gone crazy on me? What does that mean?
That means they didn't do anything specific. They were just like, oh.
Okay, if we had a non-random sample, it wasn't random.
It would be 5.
It'd be controlled.
Okay, so I'm controlling it. So, no offense, table 1 or table 3. I'm only going to ask my questions to table 2 today. That's it. They're the only ones. Is that fair?
No.
It's kind of sexist.
Isn't it kind of bad? So, or let's say I actually get you all to pull out your phones, and then when I take this poll, I specifically skip over all the Samsung people. I'm like, yep, I only can talk to the iPhone people. Is that okay?
What about the iPhone and the Samsung?
I'm going to go based off what you put all down and put on your desk. So back to this is statistics. We really want to see that R word of random. That way racism. That way we know when they targeted people, they pulled people that randomly, and not just only the girls or only the cell phone people with iPhones. Okay, and then notice their sample has 2,024 adult people. What do we call that?
A number. Again.
I think he does something.
Okay,
A
sample.
it is the sample size. So we took a sample. How big it was is the sample size. Okay, so we took the sample of over 2,000 people. So it seems pretty legit. That's a lot of people. And we wanted to see which type of cell phone they own. Do they own an iPhone, an Android, or other, including on smartphones? And here are the results. And we even have a reference because here in AP Stats, we tend to reference everything. Okay, so we see this table, we see some totals that aren't done for us, and then we see some questions at the bottom that say, use the cell phone data to calculate the marginal distribution of the type of cell phone. Hey, you know how I was going to tell you when that word marginal distribution was going to come up?
Yes.
It came up right now.
Thanks.
So we're gonna need to figure that out. Okay, I need you to be smart enough with someone with a calculator who can add 169, 214, 134.
517.
Okay, well.
Is it really?
I know.
Okay, and then I'm gonna need to know the 171, 189, 277.
637.
You know, I doubt you, and then I'll.
No, it's right. I did it.
Okay, and then I don't know why I thought he was wrong. I just did for a second. Just a second of doubt. It's over now.
Sexist.
Okay, that must be it. Okay, next.
870.
Wow, Cody.
Okay, and then let's go across this way.
I don't have these.
Why?
I can't do horizontal math.
400.
Oh, you need to leave. You got to go.
I can only do
467.
467,
503.
503,
And 1,054.
1,000 and what?
54.
54. And then what number do I put right here?
2024.
Okay,
That's gonna be
Why?
size.
Because it's sample size total.
I understand it with your sample size, but shouldn't we, did you check to make sure 467, 503, 1054 actually added up to that? Okay, cool. Did you check to make sure the other also added up to that?
Yeah.
You can see how instantly you made a mistake in discrete, because yes, you're right. Notice this did match our sample size, but by golly, these three numbers better add to that, and these three numbers better add to that, or else something went wrong. Okay, and then we go to those questions, and lo and behold, it said that word marginal distribution, and I told you it was going to come up. We just didn't realize how soon. And it said distribution of variables. I know, right? Brain.
No, we need a piece of paper.
Yep. That's what I was. That was my exact thought, Sally.
Should we get graphics to make a chart, or?
That was my exact thought. Was I probably need a good piece of graph paper right now? Do you have a good piece of graph paper you can lend me?
It's this graphic.
Perfect. And then part of me was like talking in my head about, my God, Miss Compton, why are you so unprepared? That's great.
Pretty thick.
Why am I so unprepared?
It makes for a more interesting YouTube video.
That must be it.
Just a good thing to know.
What are you doing? You look like, you know when you,
I look like I want to speak to your manager.
whenever you adopted a webkins, the person like the adoption
info?
center?
Yeah.
That's what you look like.
I feel like my name's Sharon. I want to
Oh.
speak to your manager.
You say that about everything.
Don't tackle me.
Okay, so we've got to do something with marginal distribution. And you're like, my God, Miss Compton, I don't even know what that means. I can possibly, if you're trying to be fancy, I'm going to probably fit, because I use two colors, because I am that person, I'm probably going to fit all the stuff in my chart already. But of course, if you read question 2, it does say make a graph, so I am going to need that graph paper. If you just want to do all of this on your graph paper because you're just like, my God, it can't be that cluttered, totally understand. Okay, so marginal distribution says something about two-way table of counts, distribution of values. Okay, so marginal distribution displays counts and percentages for that. Telling something about distribution to variables. It already has the counts. It's the distribution in percents. Okay. I was looking at this problem. I was like, why do we need to change anything? Everything looks good. What keyword lets me know that I'm not done? Percents. Because if we're looking at our, do we have percentages in that table right now? Oh, no. So we need percents. So I'm going to do all my percents in blue. If you're a color person like me, you can join right on in. So I need to know the percent of iPhones. So I need to do 167 or 169 divided by 517. I need to know that percentage.
What? 169 divided by 517.
I'm going to do the number divided by the total on that row to figure out that percentage. Or should I be doing 169 divided by 467?
That'd be 517.
It'd be
No.
517
Right?
because you're doing part out of whole.
It's how the types of cell phones, not the age groups. Right?
What did the problem say?
Type of cell phone.
Type of cell phone.
So not over the age group. So am I supposed to do 169 over 517 or am I supposed to do 169 over 467?
517.
467.
Why would you do 467 over
It's 517.
2024? Because that's the total number of iPhones. Right? Do it for age.
Say English again.
Why would you do 467 over 2024? Because the total number of iPhones versus the total number of collective phones.
Yes.
What?
Yes.
Yes. Do it.
Yes.
New thing.
Do the things. So he said, hey, Miss Compton, you're great. Should have done this problem beforehand. Swear to God, I'll do it in the future after this. Like you, it's the first week of school for me, too. Oh, I forgot how to do math. That's so sad. So sad.
I can't see.
Okay, so his thought was, hey, I said I was going to write in blue and then I pulled out green. His thought was, hey, it's nice what you're doing, but the different age groups, we don't really give a rip because as Sally pointed out, it said we cared about cell phone category, not age group, so why don't you just go straight with the totals of each category and do them over the total that was surveyed. So 467 over 2024, 503 over 2024, and 1054 over 2024. I need to know these percentages.
First one is 23%.
Can you give me a decimal?
22.07. Oh, 07.
07, then what?
3.
So I'll leave it 07. And then 503 over 2024. I tend to round to 2 decimal places unless I'm told otherwise in life. It seems to be smarter. Okay. 503 over 2024. What'd you get?
24.85.
Oh, wow.
Wall.
Okay, and then 1054 over 2024.
Uh-huh.
Approximately 52%.
52.1.
I don't know. I rounded to the 10, so I messed up.
You don't like have it stored in the calculator? Somebody. Sally, save me.
Sorry, I was waiting for someone else to do it.
No, Sally, you're the only one.
Okay. It's 52.07. Wait, it rounded out to 0.8.
Bless you. Okay. Now, since we are rounding, if we add those up, we might not get exactly 100. We might get 99.9. It happens. Life is hard. Okay, so it said use the supplement data to calculate the marginal distribution. We did that. And then it says make a graph to display the marginal distribution. Describe what you see. Okay, we were already told at the beginning of this that this is a categorical thing. We saw we can do a pie chart, a bar graph, or a two-way table. We were given a table. Why do we want to make another table? So we're either going to make a pie chart or a bar graph. Now, if you want, we can do a pie chart. I'm just saying we're going to tend to be bar graph kind of people. So if you want to pie chart it up, we can make a pie chart. But again, first of all, you got to have a pretty decent looking circle if you're actually going to do this on the AP exam. So if you're like me, that is a miracle circle for me. Don't know how it turned out that nicely. Normally my circles suck and look like ovals. If your circles suck, do not do a pie chart in life. Just saying. Sorry.
Depends on the day.
I know, right? It says 52% is other. So I need to go, yes, it's half, but it's a little more than half. So I'm going back to find some coloring. I love coloring. I know. See, I love coloring, yeah. And I'm going to say blue is other.
Wait, so can we do a bar graph if you want to?
Oh, I'm going to do both. Just for fun. I'm going to do both, Sally. Oh, I'm with you. I don't think it looks as good. And then another reason I don't like it is because with our specific data, like, how do you decide? Like, I get that the 52 gets a little over half. I swear I will come at you. But how do I decide with the 23 and the 24, it's almost 25? Like, they're really about even, but one gets a little more. Like, it just doesn't quite look as good as I want it to look.
Also,
Yes, you could. So you can put the numbers up there with it to try to make your life look a little less sad. That would help.
so you said you're going to do bar graphs more often.
Oh, God, yeah.
Okay. I can't tell the difference in this graph.
Oh, yeah, that's what I'm saying. That's what I'm saying is the problem.
It's part of the aesthetic.
The top right one and the left one look very
No,
similar.
which colors?
Yes, agreed. So, but again, back to the percentages are so close that a bar graph's not going to be a good idea. No, a pie chart's not going to be a good idea. Now, if our data had ended up being like 5%, 30%, and then 70-something percent,
Colors look the same.
then, yeah, they do. We'll have to work on my colors. If, I know, we are, God, you're going to make my life so special. It's already hard enough. I'm trying to do all the things. You're like, I can't do specific colors.
I'm sorry. I'm just sorry my disability so difficult for me.
Didn't you understand that in this class we were racist and then we decided to name? Oh, God. So back to, it depends on the percentages. So if we had done a different problem and we had gotten different percentages, I would have said maybe a pie chart's okay. But as we're seeing with my ugly pie chart, which is all the wrong colors, the 23 and the 24.85 are just so close together, there's really not a distinctive difference. So it probably would have been better to make a bar graph, but heck, again, they're still so close together, we're not going to be able to see much of a difference. So if we are going to make a bar graph,
Yeah.
I'm going to, let's see, have my two axes. But see, then you start getting this complicated, and why did I draw that down there like that? Yes. You could, but I've already started. Once you commit, you just can't. So iPhone, Android, you remember that for life, boys. Other. And then because life is what it is, and because I'm in a hurry and kind of lazy today, because it is Friday, instead of counting by like 10%, 20%, 30%, I'm going to, and then my minimum you add 20, 30, 40, and then my 50 is kind of up here on the words, which is always good. Always great. Okay, so iPhone is supposed to be 23%, so a little over 20.
Excellent.
And then Android is 24.85, so it's almost to 25, so it is a little higher. And then notice my intervals, another issue I'm going to have to work on, and why Sally's right in that life would be better on graph paper in general, but of course they don't give you that on the exam, is that my things, that the Android looks wider, so now the bandwidth. So now Android looks wider, so it looks more important.
I get it. Bandwidth. 'Cause
No, it actually is the bandwidth. Okay, and then 52, although that is funny because it's cell phone, that would be funny. Never mind. I do understand now.
I did never shop.
You did, my bad. And now other looks super important. And then, of course, because it is Friday at 2:58, and I just want to say all the words all at once.
It's a great day to be a warrior. We're done.
I know, right? No. We're not quite done yet. What I wanted to say is that if we, so this is part of the issue that you're going to learn in here. Now, you and I are new. And we were new to stats, and we were just simply trying to survive and finish the stupid problem. But if we were trying to skew others to buy a specific kind of phone, you can see how we could maybe count differently over here. So if we had counted by 20s, for instance, and you do not have to draw this, you just have to humor me and pay attention along. If we had drawn by 20s, for instance, and then 20, 40, 60, then the iPhone would have, not iPhone, the other would have been so high, and then the darn two iPhone and Android would have been so low. We can skew the graph and make it look like other is super duper important by the way we count our scale.
Like advertising.
So I know you're like, oh my God, Miss Compton. First of all, you said I have none of these vocab terms, and now you're telling me the scale I think is important, and it is. Because the scale you pick, you count by 10s, you count by 20s, it might make your data look a certain way. Like it make it look like other is super important, when really others did beat iPhone and Android, but I mean, it wasn't like it was a landslide victory. It had 52%. It's not like it was 75%. Okay, I swear we will come back to the things on Wednesday. Wednesday. I swear to God, it will be Tuesday. We will do math on Tuesday, people, for the love. Since people do not have textbooks, you lucky dogs, you do not have to do the textbook homework yet. If you're